Hello, my name is Terry Frith. I'm president of Gordon Technologies, and I'm here to make this video to stress the sense of urgency and importance of properly torquing an MWD tool together. As you know, there are a lot of things that can go wrong with an MWD system, but the number one concern for Gordon Technologies is the ability to properly torque the tool. The worst thing that can happen for our company is to drill in the wrong direction. So, without further ado, we're going to get into how to properly torque and check torque and apply torque stripes for every connection on the MWD tool before you pick it up and put it in the hole. There are approximately 4 connections on average on the MWD tool. If we run 2 batteries, it becomes 5 connections. You have the pulsar to gamma to the battery, battery to the electronics, and you have the top centralizer. While the top centralizer is not terribly important for torquing up, all other connections are critical for maintaining orientation before you high side the tool. So, assuming that this connection is a typical connection between a battery and an SDIM, we are going to show you the placement of the torque wrench. In this particular case, we have 2 Pulsar wrenches. When we torque up a connection, we do not grab it at the connection, we grab it from pressure housing to pressure housing. This allows us to verify shop connections as well as the field connection is being torqued up. So, first thing we want to do is to apply torque to the assembly. This was our first torque check. It's done with body weight and hands. We never stand on the Pulsar wrenches, and we apply torque. This is approximately, it's a 2-foot long handle with 125 pounds of force, which is basically half the weight of the average human being. You apply 250 foot-pounds of torque and the connection is tight, but we want to verify that. So after we apply the torque, we will attach the torque wrench. And we will verify the torque. So at first we apply torque without the torque wrench. The second we apply torque with the torque wrench. When complete, we will apply a torque stripe across all connections involved in the process. We have the pressure housing above to the centralizer assembly. Then we have the centralizer assembly to the end cap, and the end cap to the pressure housing to the next module. Once we apply the torque stripe, we will perform one more torque to verify that nothing moves. So we're going to check torque before the torque stripe is applied and after the torque stripe is applied to verify that all connections are tight. And so when complete, if we rotate it, you can see that there are no breaks in the torque stripes. This is paramount for us as a company. We will perform this task for each module attached. The next area for applying and checking torque is for the pulsar. We've just completed doing a torque check of the connection between the pulsar and the gamma module. Now we're going to check torque across the pulsar itself. So the connection where the Pulsar wrench for torque goes just below the connection with the gamma module that we just applied torque and torque stripe to. The other Pulsar wrench will be placed just above the screen housing. And therefore we are checking all connections on the pulsar itself. And we were going to apply 250 foot-pounds. Now these are shop connections. However, we're trying to eliminate potential for human error, and verifying shop connections is part of our test. Just like we applied torque to the pressure housing, they are torqued up in the shop. Also, these connections are applied in the shop, but we want to double check, so we're going to apply torque. So we'll provide the same process. We apply the weight. Also notice as he installs the torque wrench to apply torque, you may have to put weight on it. All right. So there are already torque stripes on the Pulsar. You're looking for something to break it and moving, but you just to verify torque. And so we've now checked the Pulsar above the screen housing. Okay. We cannot and should not apply a torque check across the screen housing. That is the weakest point on the tool, and it's been known to crack and break if you over torque it. So we don't want to go there. The final torque and torque verification is applied between the transmitter, or the lower end as some people call it, across the torsion bar and to the bottom of the Pulsar. Note that we use spanner blocks which grab the transmitter, and we use a 24-inch pipe wrench to hold the spanner blocks in place, and then we use the torque wrench placed just below the gill slots of the screen housing. The connections we're looking at, so there are two connections we're applying torque to. The top of the torsion bar and the bottom of the torsion bar to the stinger assembly. So we will apply the same practices. We'll put our body weight. Notice the location again of the jack stands, the pipe stands. That should be good, okay? And we'll apply the torque. Okay. In this particular case, we will apply torque stripes. And then we will check torque one more time. We'll verify the torque stripes are intact. And that completes the torque of the MWD tool. Every single connection is now checked from the transmitter to the top of the MWD tool. There's only one way to do it, and this is the right way. Any other way is the wrong way. You should have torque stripes across every module. They need to be unbroken upon completion of the torque.